Tara is our aerospace consultant. She comes to us from Boeing, and she has put a lot of thought and effort in behind what you're about to see. And to that, I will try to do justice to many of her notions, and she's a very good visual storyteller, so these slides are her construction, so I'll give her credit for where the credit is due. It's a topic, though, and a subject that I am quite passionate about. I do believe that, in general, all of us as engineers, whether we're in aerospace or we're in automotive, whether we're Tier 1 or we're an OEM, face some form of specification compliance problems, especially the Tier 1s, I think. But we all face them. And it's difficult to see the commonality across these problems. Why are these compliance problems the same? And what's emerged from the chaos is that it is a common problem set, and it's solved the same way. And what I hope to introduce to you is a way to think about compliance in a way that will universally appeal across whether you're doing compliance on a plant floor, which I'm going to show you an example of, courtesy of Spirit Aerosystems, or whether you're an OEM or whether you're a Tier 1. Okay, so if we can switch over. Oh, I don't have the, that is a problem. Coming up. Okay, so we're going to talk about next-gen compliance and challenging the chaos of the current compliance mechanisms. So if you remember from earlier this morning, Josh and Michaela and Steve talked about our core use cases and how we define them. They actually brought you through 5 of them, and I'm going to specifically talk about compliance. So I mentioned that we're starting to see that all of these forms of compliance are actually the same thing, even though they seem so different and they're attacked in so many different ways depending on where you are. And there's a conclusion here that knowledge aware is actually the right approach for compliance. And we're going to start with the generalized problem set for compliance in the most generalized sense. So let's take a look at that. And we're going to start with the assumption or the proposition that there's specs. Where do these specs come from? Here it's saying the specs can be internal or external. They're referring to each other in some ways. Have you ever read a spec that says, oh, and be compliant to this spec? Well, what is that? What does that mean? It's referring to that spec, and that spec is another 50-page document. Okay, this is not a great process to be compliant. It's not a great process to learn. It's not a great process for efficiency. So we got these specs, and what we find companies doing, and I've seen this very clearly at the Tier 1 space for sure, and also at the OEM level, and I've seen it in aerospace, and I've seen it in automotive, and I've seen it in the plant floor, and I've seen it in product development process, is that they create something that we're calling proxy policies. Now, in your vernacular, it may be something else. So it's a rule or a requirement or a standard that you've created that if you comply to will give you a likelihood to be compliant to these other specs. So you may have a whole wide variety of these in different cases. You're probably not calling them or even thinking of these things as proxy specs, proxy policies, but they're surrogates to achieve compliance to another set of documents, another set of requirements. These allow you to be more specific to your case, to your environments, to your processes, and allows you to cover these other specifications. But what happens is, how do you know that these proxies are compliant to the specification documents? I mean, that's a really hard process. If the specification changes, how do you know? If your proxy policy changes, how do you know? And if you are contractually obligated, as a Tier 1 is to their OEM, or maybe a manufacturer of aerospace equipment is to the government in some regulated framework, you're required to audit and know how compliant you are. And to say this is a zone of chaos is an understatement. To track this over time, to have it documented, what do? How does this problem addressed? It's an audit. How efficient is audit? Who likes doing audit? Anybody here tell me they like being part of an audit? Any accountants here? Oh, there you go. Okay, so audits are a way of life there. I knew I shouldn't have said that. No. Generally speaking, audits aren't a fun task. They're generally not considered to be, front of the line efficiency for doing things. So we got this zone of chaos to try to understand and audit whether our proxy policies adequately cover the current state of requirements. The next thing we see in the general case is the idea that we have the proxy policies. Now we're going to go do some engineering work, so we start to have plans. We have work instructions, we have standard work, and we reference the policies. Use this policy, use this rule set in the process of X, and that's our work instruction, right? Do our plans use the policies or the rules that we're supposed to? It's another zone of chaos where we have a great deal of error, omission, missed stuff, high effort to achieve poor quality results in terms of compliance. Next, we have to execute those plans. We got the plan. The plan says we do these policies at this time, but then we do it. Did we execute to the plan? And we got yet another zone of chaos that we have to audit for. We got to go back and look. Oh, let's go look in those SharePoint directories. Did they put the files in the right place? Do those files contain the right thing? So that we know the execution of the plan was correct and used the policies that then made us compliant to the specifications. And in some, not all cases, there's an obligation to produce a set of evidence that's published, a push evidence, right? You have to produce this evidence, and it needs to be pushed to the government or to a customer at a certain sequence, and it has to sequence of time, cadence of time, and it has to look like something. Does that documentation actually meet the specifications requirement for that documentation? And in some cases, it's actually fairly common that the overall process has to be audited. Are you functioning across all of these things correctly? Yet another zone of chaos. So this is the generalized sense of compliance. Maybe you're just doing the plan and execution, maybe you're doing the policies, maybe you're doing the specification all the way to the front, but generally there's some form of that. So we have some tier ones here, so I'm just going to kind of translate this to kind of a tier one kind of concept here. If you're a tier one, let's say you're making sunroofs, because we got one of our customers here doing sunroofs in Alpha. And you may have these proxy policies, these requirements, and you got Ford handing you a PDF of a bunch of requirements for that next sunroof system. And you got General Motors giving you something very similar with sunroof requirements. And by the way, sunroofs are super complex systems. Movable glass, all kinds of cool stuff in sunroofs. Honda, and I think the number is like some tier ones that I'm familiar with have 27 OEMs that they deal with, and they're getting similar. And if you make sunroofs, you're getting 27 different variants of this. How can you possibly know or design efficient systems that are going to reuse requirements across all these specifications? Well, you start with a proxy, but now you got this huge problem every time you get a new one. Which proxies cover what, and where's their non-synchronicity between the two? And then you got to go do it, and then you got to execute, and then you got to have evidence, a DVPR that says you met the specs, right? So this applies to tier ones. But I submit to you, it applies on the plant floor. In certain cases, it applies to OEMs. It applies to everybody. It applies to R&D. It applies to everybody. I can create this map that will fit your scenario. This is the generalized problem set that people are facing. And of course, the zones of chaos. I've never met a tier one automotive supplier who says they do a great job with requirements. So now, what can we do about it? What solution does Knowledge Aware provide to these problem sets? Let's take a look. So we're going to start with the assumption that the top of the pyramid specifications don't change. We're not going to touch that yet. So we got specifications that are referring to each other. So those are, the specs that a customer gives you. Those are the regulatory frameworks you operate in. Those are the internal engineering standards that are given to you that need to be complied during the manufacture. Important in aerospace for sure. And the first big change isn't that we have proxy policies, these rule sets, these internal standards. The first thing that we're going to do is we're going to invest in those. We're going to uplift them and we're going to make them model-based. Now, I've made a big deal here about model data footprint and what happens when we make them model-based. So when we think about model-based policies, we get a whole bunch of advantages when it comes to requirements, tons of advantages. So consider 3 policies. They have, the text representations, the visual representations, but they have the models built into them. So let's say that you're said sunroof manufacturer, and the requirement is that it has to have a push-out time of under a second and a half or something like that. And that has to do with motor current, motor size, and these other requirements have similar parameters. When they're model-based, we start to evolve an ecosystem of parameters. We call this property called parameter threading. And we've got really good examples where customers went to model-based policies and the problems that get resolved through parameter threading. So meaning we can start to relate these requirements in a digital way without having to track them by hand. So here is an actual specification where the policy has been pulled out of the paragraph in the PDF. And it's got a chart here, and it's got some data. It doesn't really matter what the words are. But what I want to show you is it's been turned into a model-based requirement. This isn't just a table. That's a model. And this has to do with temperature shock or something like that. And there's a bunch of different parameterization of how to measure that temperature shock and what's accessible. And once it's a model, we can test it, right? And so this is an Auros window where I'm just looking at the policy. It's not in the context of any validation. And as we start to know numbers, it can start to derive, what are, in this case, a min and max temperature for the shock. And it's basically resolving, and as it resolves, it produces some level of compliance or completeness at the parameter level, but also at the policy level. So individual parameter, and it's producing, when it's in an assessment, a model data footprint of what happens. So this is, the first screen you saw was what it would look like if you just pulled it out as text. This is it actually being converted into a model, right? And so now you got a model representation, a granular, modular, actionable policy that we can get to wherever it needs to go in our validation processes. Okay? So this is an important concept, and we're going to build on this. So now we got our model-based policies. Now we got our plans. Same thing. Why have plans that are written procedures? Why not model the plans? Now Josh showed you a plan from Spray Systems about a process that does the business processes. Well, the plans can also be plans to be compliant. And so here's just a simple example. It actually looks a little bit like Josh's plan there, but it's completely different where the policies are enacted in a sequence, the policies are enacted, or rules or the standards are arrayed in a certain way that validates processes. So now it becomes even more important to automate the connection between the policy and the specifications. Why? Because instead of just having these proxy policies, we've invested in them. We've put some time into them because it takes a little time to convert them to model-based. It's going to unlock a ton of value, but now we've got them. I don't want to have to recreate them every time someone gives me a new specification, anytime someone changes. So what we see the state of the art in industry is people have specifications that are doing something called spec shattering. Which means the thought process is we're going to take the spec and we're going to break it into bits, and then we're going to chase those shards all the way through our processes. But if you've got proxy policies, which you've already said are valuable because they can cover multiple specifications and we can build to our own, if the specs are changing now, we can't just uplift every shard. We have to have some more durable way to do this. So what our R&D at Auros has been investigating is this idea of reverse attribution. So reverse attribution is a technology we're working on that will allow us to take a proxy policy, a requirement, a modular, unitized unit of spec, and take the policy and match it in reverse attribution to the spec. So I know some of you are technologists out there, so you'll like to know there's a knowledge graph involved, there's a large language model involved, there's a whole bunch of different techniques we're using, some clustering stuff to make this work. So I cannot tell you that that you can buy a license of this today, but I can tell you that we've taken this far enough that I have a high confidence we're going to be able to get it to a level of fidelity that will make this absolutely fly. So we're affectionately calling this reverse attribution. So if you got proxy policies and you want to understand, given a grouping of proxy policies, how well does it cover across a multitude of specs? Here's my proxy policies for a certain kind of sunroof. How well is it covered in Ford, General Motors, and Stellantis's trucks? We can do this kind of reverse attribution so that our proxy policies become far more durable and we can invest in them. Once we have model-based plans, model-based policies, and the reverse attribution that takes us out of the zone of chaos for compliance, here's where the magic happens. This is where the value really starts to happen. Now we instantiate, we activate the models. We put the values in those models, we put the plans into action, and we get the model data footprint. We don't have to audit for compliance anymore. So I gave you guys all the example this morning, right? If you used a map to get here, we don't know how fast you drove. We don't know how fast you're driving in mile 2. We don't know how long it took you to get here. Who had the fastest, on average, per mile time to get here? What can we learn about how they drove, right? If you had just the traditional process, you wouldn't know that. You would have to audit for all that, and you could never audit for all that data. But if you're instantiating the model policies and you're instantiating the plans, the model data footprint of how the model instantiated, what happened at whatever granularity is necessary, you'll have all that data, and you don't have to know the answers you want before it happens. You'll have the data, and whatever query you want to have, you go to the data and deduce the answer. In the same way I can go to if you all had your trips logged in the mapping system, I could give you the average time to here. I could give you who got here the fastest per total, discrete time. It took someone 5 minutes, it took someone 2 hours, or per mile, the fastest. Let's think of something interesting analyzing your travel. We could only do it if we were doing it through model interaction and not through a passive interaction. Does it make sense where the value comes from here? I got 10 minutes? Wow, I'm really far off. The auditing becomes just a matter of inspecting the data, and there's no after-the-fact audit if we can pull this off. Okay, we're theorizing a future state. I'm going to get to this a little quicker because I'm running out of time. That there's a third stage where we cause the authorship of the specifications to change, and those become model-based. I'm running out of time, but I will theorize for you that the conclusion is that the authoring and the publishing of these specifications will be easier, faster, and more robust, more traceable, trackable by doing this. The proxy policies are no longer authored as separate entities. They're subscribed to. And there's a process that we're theorizing, and this is we're a little further away, that we call translocation right now, where the proxy policies are subscribed to and they're specialized. It's a form of instantiation, but not quite the same thing. And then the proxy policies then get replaced with the actual policies as written in the spec. We believe this will reduce a ton of noise, a ton of ambiguity in the process of interpreting specs, and I'll give you reasons why we believe that. Okay, I'm going to skip, I only have 10 minutes. I was going to show you an example of information security management policy stuff. We're an information management company. We host software for Spray. And in doing so, we have to be compliant to ISO 27001, as I'm sure many of you. And we have to prove compliance. Guess what? We're doing this. We're creating model-based plans, model-based policies, and we're making that process work. Kurt, where's Kurt? Kurt, you around? He stepped out. He's our information security management guy, and he runs all the stuff. And we see the benefits ourselves in understanding how we're compliant to 27001. I want to go to this guy. So this is going to be an actual example from Spirit Auros Systems, and it's not going to be the kind of specification compliance you normally think about, but it is the same thing. This is specification compliance to airplanes as built. So I can give you this because he presented with us at a conference in where were we? Phoenix, 4 or 5 weeks ago. So in this problem set, they have to produce work instructions to get things heat treated the right way. And the traditional work instruction said, hey, make sure it's heat treated per spec for hardness, for solutions. And these are 100-page PDFs. Can you imagine you're a process engineer trying to figure out what the right work instruction to write is for the mechanic who's building the plane? And you got two different guys. One guy had a good breakfast, one gal had no breakfast, and the answers come out different simply because they're in different moods, because your willingness to traverse the specifications in detail is not the same. They did get different answers. It's a scary thing, okay? So what they did is a single guy said, I get this. We're going to make this work. Now, he does not have the advantage of reverse attribution, but he did create the proxy specs because the specs are they're pretty much, they're not changing. So in this particular case, what's happening, and I got some really good examples, is that the specs have been turned into discrete proxy policies represented here. So if you see set 312, if you're an Auros person, you know a set is a collection of these proxy policies or a collection of these KPACs or knowledge packets. And that set contains other sets. And those sets contain these policies, these model-based policies. So this is one guy doing all of this. And all of these sets then chain together through parameter threading, which I mentioned. Now this is parameter threading probably isn't something you've heard a lot from us yet, but as you get into the model-based world, parameter threading becomes a super important concept to combat complexity. And when you get into so what we're doing here in this slide, and this was actually authored by the guy at Spirit, is inside the set, there's sets, and inside that set are the knowledge packets, and inside those knowledge packets are the rules, and inside the policy models, and inside those policy models are parameters. And these parameters are the same in different policies, and Auros Rules Engine is able to thread them. It knows it's the same parameter, the values are getting passed, and you're getting complex sequences of values and derivatives happening to traverse the specifications deterministically. So here's an example from the production footprint here. This is a proxy policy he created. This one has a text input that then produces a value and a secondary value, and when that policy is evaluated. So it's very similar to the one I showed you earlier, but this one's very specific to his process planning system. And if he changes these values, obviously the model is reacting and giving different answers. And if we zoom out to the set of sets, we got multiple proxy policies. We can rule process that. I kind of just skipped over that. But you get just a longer list of parameters, right? Oops. I don't want to get to that one yet. Yeah, I'll go there first. Sorry, again, Tara's better at this presentation than I am. I particularly love this particular view. I mentioned parameter threading, and it's important. So imagine all these people, you've distributed this across your organization, and people are creating these proxy policies. They're reusing these parameters, because Auros has some parameter librarying techniques. And the system now can start to map out the interfaces of the different parameters. Right? So as you mouse over here, any of these parameters in the space of of these proxy policies, it's telling you this parameter is related to these other parameters through these models. And if I pick on one of these parameters, I can look at the different communities that are using those parameters, the different proxy policies that use those parameters, and what other parameters are used in a given proxy policy. This is mapping out the space bottom-up organically. This is not a top-down trace, which allows us to really manage a lot more complexity otherwise. So in the end, because I'm out of time, what happens is there's a tool for the product planner. They built a low-code interface over the top of all of that, all those policies that are giving them protection for the specifications. And there's some debug things on the right here that as they just do these very simple selections, it's traversing the entire possible space. And I can't remember what Darwin said, the guy from Spirit, but there's like billions of possibilities through all the possibilities. But here, there's just these selections, and it's traversing these sets and these proxy policies. In the end, it comes out with some kind of hardness number, some heat treat specification stuff that would have otherwise been left to a process planner to look through these specs and decide what's what. And Sarah, do you remember the number he's saying this is happening how many times a day? It was like 10,000 times a day?
10,000, yep.
10,000 times a day. And this is one guy did all this. One guy did all this in about a year. It took him about a year. But this is one guy. So that's the story for specification compliance. It is a story of taking knowledge aware and applying those concepts to a model of compliance, the most general case that we could come up with. And again, I do think it applies to OEM. I think it applies to plant floor. I think it applies to written specs, other internal specs. But where you need to be compliant, the knowledge aware solution or idea would suggest, as the gentleman from GM has told you, that as we activate through assessments, through models, we get a lot of value. You get the model data footprint, and a lot of good things happen.
Yeah, Jeff, you keep mentioning models. Can this be done with CAD models to check their compliance to specification?
Yep, it's as Steve was talking about earlier. Again, I'm going to keep pointing people to either Steve or to Daryl over there about CAD stuff. They both have a lot of experience in integrating these models to other modeling systems. CAD is just a modeling system. So we got a model-based specification expert here in Alec. So yeah, this is the kind of thing we want to do. We think models should be service to other models. Knowledge models should enrich the modeling tools that you use to get work done, like CAD.
All right, you talked about this happening at Spirit Aerosystems. Can you reference any other companies that are executing this approach?
I mentioned that we are doing it in information security management. One of our core use cases is requirements management. We're working with multiple companies on requirements management. The vision for this is fairly immature in those deployments, but it's all moving that direction. So I think there is a production footprint for this, but it's a very big topic, right? What you may do in your requirements process, your compliance process may be different than Spirit, but conceptually it's the same.
In our process, we audit multiple times throughout a design, and it's painful. What you've demoed is an audit that happens continuously. Is that correct?
Wow, that sounds like a layup. Stick the ball in on the rim. Yeah. I mean, fundamentally, that's it. If you look at the maturity model that Steve Boisver presented, I think it was Steve's. Who did requirements? Was it Tara? Or was it Michaela? Yeah. The idea for maturity of design review is you go from a synchronous event to a continuous process for design review. And you're always reviewing the design. It's continuous. All the expertise is brought to bear in the design process through knowledge models, and you get a continuous risk reduction process. And you're not reviewing it and going, have to change things way back at the beginning of the process where we all know it's more painful and more costly. But yeah, the main idea is continuous design review from the discrete synchronous design review.
Any other questions?
All righty. Thank you.
Perfect timing.